Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Cyclotetraene, COT, is an 8-membered ring with 4 alternating double bonds, formula C8H8. To assess its structure, we apply Huckel's rule and consider the energetics of planarity. Moving on to the next step. For a cyclic conjugated system to be aromatic, it must be planar and have 4n plus 2 pi electrons. COT has 8 pi electrons, n is equal to 1 gives 6, n is equal to 2 gives 10, so 8 is equal to 4n where n is equal to 2, making it antiaromatic if planar. Moving on to the next step. A planar COT would be antiaromatic, 8 pi electrons, 4n rule, which is highly destabilizing. To avoid antiaromaticity, the molecule distorts out of planarity. And for the final step, COT adopts a non-planar, tub-shaped or tub conformation. In this geometry, the p orbitals on adjacent carbons are not parallel, so conjugation is broken, the molecule behaves like a non-conjugated polene, and antiaromatic destabilization is avoided. This tub shape has been confirmed experimentally by X-ray crystallography and other methods. A planar structure would force antiaromaticity, not observed. C. Open chain isomeric structure is not what COT itself has, COT is cyclic. D. Tautomeric bicyclic structure, bicyclo, 4.2.0, octa 2,4,7 triene, is a valence isomer tautomer that exists in equilibrium with COT at high temperatures, but it is not the primary expected structure of COT itself. Therefore, the correct answer is B. Therefore, the correct answer is option B.